Okay, so this is probably the trickiest of all the quadrilaterals. So in this case, we're going to prove that this quadrilateral is an isosceles trapezoid. All right, so I'm going to try to cover two in one. So what makes a trapezoid is that one pair of opposite sides are parallel and the other pair are not. Um, what makes it an isosceles trapezoid is pretty much the trapezoid that we all envision if we remember what a trapezoid is, which is our just our stereotypical trapezoid. Looks exactly the way that mine does here in red, probably not tilted of course, but what makes this the case is that this side here and this side here, which are clearly not the two parallel sides, but those two sides also wind up being congruent. So if the congruency doesn't exist, you just have a regular trapezoid. But if the congruency does exist of these two non-parallel sides, then it's an isosceles trapezoid. All right, so we're going to go through this now, just like we've been all the others, and we'll make sure you understand. So what you're going to do for this one is you're going to wind up doing four slopes paired. So again, they'll be paired by opposite sides. So we do the slope of TR, so that's this side here, and the slope of AP, so that's this little guy here. And if you look at them, they look pretty parallel. So you should expect these slopes to work out to be the same. Now, you do the calculation for the slope of TR and the slope of AP. Now, when you do that, for one, you're going to get 9 over 12, and for the other, you're going to get 3 over 4. Now, a lot of kids then think, oh, then these are not the two that are parallel. But with a trapezoid, you're always going to wind up having to simplify one of the slopes. So this slope of 9 over 12, of course, simplifies to 3 over 4. And then boom, just like that, both of these slopes are the same. All right, so the eye test has got to be very helpful for you here because you should know that these two sides are the ones that work out to be parallel. So you conclude TR is parallel to AP. All right, then we do the other two sides. And we're going to show the slope of TP and the slope of AR, which if you look at it, those would two totally intersect if we extended them. All right, so you should not expect these two to work out to be parallel and therefore have the same slope. So you go through the slope calculations again, change in y over change in x. This one's going to give you a slope of negative 11 over 2, and this one's going to give you a slope of negative 5 over 10. They are not the same, so you will conclude that TP is not, with the line through it, parallel to AR. All right, so all these calculations, and we talked about this in the very beginning, sure, you use slope to prove parallel, but it also proves not parallel. You use slope to prove perpendicular, but it also proves not perpendicular. All right, you can use distance to prove congruent, but could also show that they're not congruent. All right, so you keep going on here, and now once you have these two that are therefore identified as the non-parallel sides, right, TP and AR, now you calculate the distance for these two. All right, so time out. If we stopped right here, all right, the part that I'm going over here, if we stopped right here with the four slopes, that would be your slope for a trapezoid. Excuse me, that would be your proof for a trapezoid. And you would have a since statement that says, since one pair of opposite sides are parallel and the other pair is not, blah, 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 is a trapezoid. All right? But since this is identifying and asking for you to prove that it's an isosceles trapezoid, you need to go this next step. All right, so you take the two sides that are not parallel and you calculate the distances. Now, this is kind of a unique distance formula calculation because you'll notice they both work out to be the square root of 125, but with different numbers inside. This is 2 squared plus 11 squared, and this is 10 squared plus 5 squared. So you always have to make sure you're looking at the coordinates carefully and making sure it works out the way you expect it to. So both work out to have the same distance. Therefore, TP is congruent to AR. And you're good from all your mini conclusions and all your calculations. Now the since statement, and this is probably the most annoying since statement of all the ones we do. Since one pair of opposite sides is parallel and one pair of opposite sides is not, that's a bad typo right there. That should say is. Both of these should say is. Bad grammar, bad cooch. All right. And the non-parallel sides are congruent. TRAP is an isosceles trapezoid. See, TRAP, trapezoid. See what I did there? All right, so I hope this made sense. This was definitely one of the longer ones. If you got to watch it again, you watch it again. All right, have a great day. Jump.